Good morning, everyone. Waiting for Carol Ann to finish her breakfast.
I wish. The waffles are sitting there calling me. Yep, good morning, everyone. Thanks to all of you who are here on a Friday morning and those of you who are online on I don't know if anyone's online on their Thursday or on their Thursday night. I'm bad at the time zone thing. But those of you who are on extra early Friday morning or Friday afternoon or whenever you are on, thank you for being here with us for the last set of breakout sessions and discussion that we're going to have. So as we've been going through the different discussion groups and I've been trying to sort of put this together, I thought, I really want to heed something that Elizabeth and Justin said in their discussion group. We really need to start putting some kind of hypothesis together to sort of drive this, because we've had a lot, as I said, there's a lot that we don't know in our field, which is great, right? Because then, we can write down science questions all the time, but we need at some point to start making this look like a coherent thing that really helps us to hone in on what kinds of modeling efforts do we need, what kinds of observations do we need, what planning will need to take place before this happens. So I have done a straw proposal. I was about to say straw man, but we say straw person? That doesn't make any sense either. So I'm going to do a straw proposal, which any little pig could blow down easily, I guess, about some kind of hypotheses. And again, I'm going to take the prerogative of not actually displaying them up there and just sort of talk through them so that we're not entirely wordsmithing the thing. But so here's what I'm going to go with. And I would love then to have some discussion on whether that seems like at least a sort of a framework that we could begin to work with or not. So here's, I even wrote it as a quasi-hypothesis, because I don't want to yet get into the, is it a testable, what would the null hypothesis be? I'm just something, right? So if we start off and we say this is just, it's a hypothesis, all right. The coupled boundary layers in the Gulf Stream region affect subseasonal to seasonal variability in the North Atlantic. All right, North Atlantic not being the ocean, but North Atlantic basin atmosphere. So, see, I'm already wordsmithing my own words. Okay, that's a hypothesis. So the next step from that is a prime mechanism by which this happens is by the episodic storms that move through the region. Those are a key feature of that predictability. And then the final step of this is hypothesis is that the structure and evolution of the storms is highly impacted by the coupling between the ocean and the overlying planetary boundary layer. So I should have said marine boundary layer. So we're starting off, so again, we say the coupled boundary layers in this region are affecting something a little longer time scale, subseasonal to seasonal. There was a discussion in our discussion group of what that is. So typically like 15 to 90 day. So it's not interannual and it's not from season to season necessarily, but that time scale. And that the next hypothesis is that storms are kind of key to that predictability again. And we could get into the, by the impact on the jet stream and storm tracks and all of that. And then lastly, that the coupled boundary layer system itself, including, the gradient of the SST and so forth, is impacting both and I could have said, the genesis, but the structure and evolution. So, from genesis to life cycle to death of those storms. So, thoughts. It's good to do this at 8 o'clock on a Friday morning because people aren't yet awake. So we might just get something through before people notice we've
I like procedural, yeah, trickery.
Jimmy.
I have a thought, but no.
Oh, yeah, sorry.
You're not allowed to think without a microphone.
Next time I'll gavel you. Stop.
So I think all of those things are true, and I think the difficulty in proving it with observations is the amount of variability in the atmosphere. So if you have the same storm coming through and these characteristics of the ocean heat flux convergence or SST change, it would be observable. But because the storms have such vast differences in flavors and the synoptic scale at which they're shifting either north-south or where they're intensifying makes it difficult to see that signal. So I think everything you said is occurring, and that the difficulty will be observing it. Challenge, yeah. The challenge.
Yeah, and we don't have to believe that we don't have to believe that the hypotheses are true. We have to believe that it's a possibility, right? That that there's enough out there, or at least that it's a question, right? Some people think yes, some analyses say no. It's an open question, right? But I think that is a really good point. And so one question then could become, is that challenge so great that we can't come up with a plan to address these hypotheses, right?
So, Carol Ann, just quickly, I was going to add something about the climate, which is just that the combined effect of these processes has an influence on the climate. So it's more of an assertion than a hypothesis, I suppose.
The climate piece is an assertion, or my hypotheses are assertions?
Well, sort of in view of, in view of Jimmy's comment, maybe the climate and what we can resolve in this sort of an program, the climate piece is a hypothesis, an assertion, the climate piece.
Yeah, and I would definitely, I would agree with that there is sort of that, and then, so by doing this does not link to all kinds of climate questions. All right, what implication does that have if the Gulf Stream becomes weaker, more diffuse? How does the cumulative effect, as you said, of all of these on the atmospheric circulation, what impact does that have? So there's definitely climate connections in this, and I think if we're going forward with this, we would definitely want to call those out. This has longer term implications than this, and then the question just becomes sort of an intractable problem for us to do. But what that also then says is that one thing that I've heard from multiple discussion groups is when we're structuring this, the desire to have at least the possibility of some assets remain in the water as a legacy for longer periods of time. And I think a prime example of that would be if we have buoys, or a buoy. I'm not constraining the number of buoys or the location of the buoys or anything like that. But if we had a buoy or something similar to a buoy, a long-term something in the Gulf Stream, north of the Gulf Stream, south, wherever that is, to have that become, say, an ocean site, right? And to keep up some of the long-term, measurements, right? And that has definitely come through. That would just be, I think we would just talk about that and the desire to continue that on, but that we would not, as part of this study, be doing this for 10 years or 15 years, right? We would make that available. Oh, sorry. Oh, yeah.
Yeah, so the hypotheses about the impact on seasonal to subseasonal to seasonal scale prediction is easily testable with some of the model suites out there, the seasonal and subseasonal forecast suites that are out there. There's a WCRP S2S entire community that just publishes these things on websites. There's a US one, the SubX, NMME, those things are out there and available for testing these kinds of hypotheses, you know, in the large, you know, over many years and over many cases, does the behavior of the Gulf Stream affect seasonal prediction in the North Atlantic? That could be easily answered with the models. I don't know that we have to observe every single time something with the Gulf Stream interacts with the jet and impacts the jet. The aggregate can be gotten from the models, and then the observations, of course, are needed to make sure that what the models are saying makes sense.
Yeah, so I think that makes it, because exactly. I mean, a lot of this is driven by model. These are not hypotheses that are really driven so much by observations as they are driven by model results, right? And so then that's really interesting, because then the question is, I'm not sure if I thought about it for a long time, I would put it this way, but the question then becomes, what observations are needed to allow us to, you know, understand if the models at those scales actually have the right coupling, right? And when they're missing physics, when they don't have the winds, waves, currents coupling in there, you know, is that a fatal flaw, right? And if they have that in there, then all of a sudden they, you know, and then the question is, okay, if you get that in there and you get that in there in a somewhat physical way that we think, does that go away? Like, you know, what impact does that have?
Carol Ann, we have two comments or?
Okay, and then to Larry. So I only see one comment.
So, yeah.
Okay, Young Ho's got a hand and Chris has got a hand. And did Ben beat them?
I don't believe so.
So Larry was first.
Larry, then Young Ho, yeah.
Okay, so it's going to go Larry, Young Ho, and then Chris, and then Ben?
Yeah.
Sure. All right. So go ahead, Larry.
I'll keep this quick. I just want to underscore your point about or go back to the point about resolving climate scales. And if you think about climate scales as being like a time mean, then I think of the work in the last 10 years especially has really shown that the synoptic variability contributes to the time mean in a non-trivial way. And so to resolve even the climatological means, we have to resolve the synoptic scale variability over a longer period of time. So I'd really advocate for, you know, some sort of longer term type measurements that can, you know, get an idea of what the climatological mean is and how it varies, because that is the climate scale.
Yeah. So who is next? We said Young Ho was next. Young Ho, go ahead.
All right, can you hear me okay?
Yes.
So I think we may think about two-track approach. So the coordinated observational campaign that we've been talking about a lot can do excellent science, and there's a lot of questions out there that can be addressed. But also there's other aspects like Jimmy or Larry just point out that cannot be addressed with a limited time observational campaign. So I wonder whether the problem is bigger than that, and perhaps something like science team approach could be initiated as well, like the AMAC science team, which just have been ended. So maybe the Gulf Stream science team is a good thing to follow AMAC science team.
Yes, that's a great suggestion. And that does lead into the question of, you know, so that was why I was carefully wording in the hypotheses to keep it sort of at the smaller, shorter time scale, right? Just because that is sort of tractable, exactly as Young Ho said, like a more limited time field campaign. But could there not be a corollary or the additional part of this in which it is a longer, you know, then the climate questions start to come up. So during the discussion today, I think that might be a really useful thing for people to, you know, to think about in there. So is Chris next? Okay.
Hi, sorry, I just wanted to come back to this point that we have these large databases of S2S forecasts or SubX, and we do, and they're fantastic resources for looking at various different things in the forecasts, but generally these models are run at quite low resolutions, or the typical resolutions. We're not resolving mesoscale eddies. We know we have the Gulf Stream in the wrong place, and we're not coupling them at comparable resolutions in the ocean and atmosphere. So there's this question that we are systematically missing processes. The question is, if we suddenly were able to resolve all these, this would have some sort of transformative effect on our ability to represent these air-sea interactions that would have some follow-on impact on our weather and climate forecasts. So I think that you can't use the models we have already to sort of authoritatively say one way or another, this is the impact of a change in the Gulf Stream here, because we think they might be deficient in some way, and that's where having the observations and confronting the models we have is useful.
Yeah, Ben's next. Yeah, okay. So for those of you who can't see the chat, which I barely can either without my glasses, obviously, do you want to read it?
Yeah, I can read that. Okay, so Ben Barr is saying, in the chat, another corollary hypothesis might be the coupled boundary layers and air-sea interaction affect predictability when storms are not present. This could be testable using long-term observations and models, and maybe reanalysis, that are not subject to the strong variability of storms. That's a great comment, I think.
Yeah.
And that kind of circles back to what we were talking about yesterday with wanting to get the background conditions right. So.
Yeah, so I think
Yeah,
if I might just add on to that. So this is a nice, so I like your hypotheses, Carol Ann. These are focused on the interactions, including storms. But it would be good to know whether or not we can just disregard the variability when storms are not present, right? Because the Gulf Stream introduces variability with its shifting, even when storms aren't there. And so if we could somehow figure out the impact of that, that would be another really nice kind of, that would help us know what the effect is when storms aren't there, which is a large portion of the time.
Yeah, so this is really terrible that I can't remember all the right terminology for that. You have a null hypothesis, and then you have a, is it a corollary hypothesis? But it's the hypothesis that's this other one isn't true, right? And that's kind of where you are. Like, and that, I would say that's 100% why we need to be there for not just during the wintertime storms, is for exactly this reason. Yeah.
Yeah, and I just wanted to I wanted to follow that because of just the huge signal to noise in this region, from my perspective as an air-sea interaction guy, you really shouldn't discount the power that a long time series has. And in my case, it was 15 months. The spatial and temporal scales you can investigate with a single mooring in this really highly variable region of the Gulf Stream shouldn't be discounted. It was my point, that you can learn a lot about what Ben is talking about here by measuring continuously through the 4+ seasons, and from a single mooring you learn a ton, and so adding to that is just gravy. So I just wanted to make that point.
Yeah, I actually wanted to mention a similar thing. As we discussed this, we could think about again, this two-pronged approach where we could have one observing system that that measure these various conditions. So I think there was emphasis about the observation system that measure wide range of wind speed, wave age, and stability conditions, so that we have a right parameterization, right physics in the model, and it can be improved upon the data sets. And then we have this sort of the rapid response type kind of observation that can sample both preconditioning effect as well as the storm active interaction with the storm and ocean. I think that kind of approach can cover the Ben's comments where I think this signal to noise ratio can be very important aspect of this capturing right variability that is related to storm and the ocean atmosphere interaction. So Yeah, I really like this Ben's comments and then Jim's response to that. Yeah.
So perhaps Carol Ann's quasi-hypothesis about, or maybe, I don't know if it was the hypothesis or the quasi-hypothesis, that storms are really a prominent driver of this. Maybe that's not testable observationally because of all the variability that Jimmy mentioned, but if we improve the parameterizations of air-sea fluxes in the models using really intense observations, then maybe we can begin to do sensitivity analysis in the models. And I don't want to say turn off, that sounds, turn off physical processes, but reduce the variability and just focus on the, the effects that we're interested in.
Yeah, I wrote down the same thing in my notes.
I'm not going to get caught by that clock. Glenn.
I'm also wondering if the type of storm, thinking about the types of storms, and thinking about the seasonal transition cutoff lows that might be moving very slowly as opposed to the bomb storms that move very rapidly. One might have higher fluxes but much shorter duration, whereas the others might be lasting longer. And Reese actually made that point yesterday, informal discussion. So.
Right. So, definitely I think a next step could be, we have the climatology of those storms. Reese even has that it's Reese, he's not here. So I'm sure he has it by various types of storms and, how often and where they happen all over the place, right? And so just even so asking ourselves then, what kind of a length of time of observations of some kind would we need to have to capture, enough of the different flavors of those storms, I think that's kind of a follow-on question, right? So some of what we're going to do with the discussion today is exactly, say to ourselves, okay, well, if this is what we're going for, what do we need to know before we could actually do the experiment? Right? And when I say the experiment, it's the putting out the observations, it's the modeling associated with that. Let's, just as something. So I think that's one of the key things that we're going to try, that we're hoping in the breakout groups today for people to be talking about. This is we kind of motivated us on what do the models know and what do they not know very well, right? That was a question. What observations do we have pretty well on some kind of a grid, and what observations do we not have in any shape or form? And then so that, then the question then becomes, I'm still not clear in my mind whether this is something that should occur near the separation region, out over the extension, or as some of you are happy with, both. To get both, right? I think there's, I think that would be an area that we should perhaps explore, but we may not have the, best answer right now. So, yeah.
Yeah, in terms of where you might put observations, a conversation that I really enjoyed with Andrea was one that she said that I hope I'm paraphrasing, okay, that we can use the ensemble models of S2S predictions, perturb them in different locations and see where our S2S predictions in various regions are most sensitive. And that could provide a useful guidance. I thought that was a great guide type of possibility for the future.
Yeah, that's a great point. And that came up in our group discussion yesterday, I think after your conversation with Andrea. We have a comment in the chat, or a question in the chat from Luann Thompson. What are the sustained observations that will contribute to the experiment? We should also answer this one. For instance, satellite data. Great point.
I just want to comment briefly on the location that if we're interested in storms, then the frequency of storms in whatever location we choose is potentially important.
Yeah, that's a great point. We don't have to go fishing for storms, but if we go in a place where they're known to be found, they will come upon our instrumentation.
And I would say if you're in the North Atlantic, you're getting storms, but that doesn't answer, is there a type of storm that is that is more important to capture than another? And is there some preferential region where the Gulf Stream, for instance, has the most impact, appears to have the most impact on that storm? You know, is it when it hits this sector or that sector, or if it's this type of storm or that type of storm? So I think there's a lot of questions that are inherent in Roger's statement.
Yeah, so looks like Elizabeth. Elizabeth has her hand up.
Yeah, I was just gonna ask whether it would be appropriate to sort of motivate or ask for sort of like a pre-field campaign analysis set of analyses that rank or prioritize the biggest errors in models or the biggest priority regions like sensitivity studies, or is that possible with the current suite of models? And that could include too, what are the biggest ways in which the Gulf Stream impacts climate and weather? You know, could we fish out some of these most pressing details, or are our models insufficient for that? Or this could also be an observational analysis too, like comparing observations to models that we have, or do we already know where the biggest errors are? I'm just trying to think of how to prioritize and answer some of those questions about where and when and.
Yeah, that's a great point. So today is the perfect day to really make some decisions and put down some priorities. We have about 2 minutes before we break out. So maybe that is a good little thing to have linger in your head. Always be considering the priorities, because we're going to have to be making some trade-offs when we put pen to paper.
Yeah, and I would just follow up by saying that that's the approach that the last NOAA CVP program took. So the TPAWS field campaign might happen, you know, in the next 5 to 6 years or whatever, but they funded recently 3-year proposals just to say, what is the analysis and model development that we need to do ahead of that to motivate or guide the field campaign decisions? And so that's one, that's a path that the agency took to set ourselves up for success. And I feel like we could use that as a model here.
Yeah, and I would echo that and say, you know, another thing that NOAA did is they invested in different types of observations that they thought might be useful that are close, some of which they used, sadly the DCFS not, but that was also a part of it, right? Is there something that we would just like to see, put it out there, get it going, is it have something that we can do? So Jim, this is last comment, because we got to break.
Yeah, I almost don't need to say this, but I thought we whipped through Luann's comment pretty quickly, right? And that's really important, you know, thing, because you could have a single mooring in the Gulf Stream, for example, and then a ton of NDBC moorings outside the Gulf Stream to look at that contrast those two. But it's remote sensing that you really want to tie that all together. So scatterometry derived winds, for example. So that's just a really important question that I think we're trying to answer about observations.
Yeah, and then Arnaud and Justin, I'm sorry that we couldn't get to you, but we're about to break out. So maybe.
It's a half-hour break. Can we? Is it okay if we ask them?
Okay, so we're making the executive decision to override our schedule. Justin.
Elizabeth's question about problems in the models, and made me think of the separation problem, which everyone knows about. But then I thought about further downstream. There's a big issue in most climate models of a kind of cold spot or the central North Atlantic, which is, I think, partly due to the North Atlantic current representation. So that made me think, well, there's some downstream problems in models. I don't know if this experiment would be suitable to look at that, but maybe it might be an application as to whether any processes in the upstream Gulf Stream and SC interaction might impact the downstream kind of cold spot in climate models. So that was just one comment.
Yeah. Great. Arnaud?
Thank you. I was just thinking as well related to Elizabeth's question, in terms of impact of the Gulf Stream on the mesoscale circulation in the atmosphere. I think there's already quite a lot available in terms of maps, people, isolating which location air parcels would become most unstable, and pretty much all these analyses always point to the separation, and so there's clear things we could look at and test, in terms of mechanism which might be absent in climate models like the slantwise convection. Or so there's a lot of resources in terms of mesoscale meteorology and maps to guide the experiment.
Yeah, that's great. So I think we've got plenty bubbling around our head that we can begin our breakout discussion.
Okay, I'm in. I have all my virtual AV equipment working. So this was a combined virtual session. Myself, Justin, Roger, and Ben helped. And so we had a lot of detailed discussion about several different processes, but these were sort of some of the bigger takeaway things that we thought would be important for communicating for the report. One is that multiple rounds of funding opportunities and concurrent model fieldwork activities are needed. In the pre-field campaign phase, innovative modeling experiments and development of modeling in terms of analysis and pre-field campaign planning is needed, and I have more details on that in the next slide. We really like the idea of maintaining a Clybar Gulfstream team, and pilot experiments for promising observational platforms and strategies could be put in place then too. And then in the, let's say, like big active phase, next it could be the field campaign and new process-oriented modeling with new data. We talked about how coupled DA in like near real time could be useful, but we also mentioned that this is a new field, and it's obviously going to be an important part of any advanced modeling system, but it's very new, and so it could be explored. And then after the field campaign, we'd want further analysis and model experiments to synthesize the data and the learning. Next, please. So we struggled with the idea of how to rank priorities for research questions, physical processes, etc. It's really hard to pick between all of the really great research priorities and topics that were brought up this weekend or this week. So we suggested that a ranking be produced by a new effort to evaluate models, data assimilation, reanalysis, OSSEs, and parameterization suites for their ability specifically to represent Gulfstream processes and their impacts on weather and climate. Obviously, people have presented work that some of this is already in process, but a synthesis of that and a focusing of it could be recommended. And that would be before the field campaign. The idea could be, and a new aspect could be hindcast experiments or evaluation against past Gulfstream field campaign data on relevant analogs like tropical instability waves or other mid-latitude cyclones, and available operational data. And with a side note that a report could be produced on what all these past field campaigns were. We learned a lot about them this week. We could produce a report that ranks or prioritizes the leading sources of error and the leading physical processes responsible for determining the modeled Gulfstream state and its impact on weather and climate. The international community and cross-agency collaborations that we formed this week could remain intact, informed, and motivated by the formation of a Clybar Gulfstream science team. I think this is particularly important with our hybrid telework presence that could continue. A best practices, or including lessons learned document, could be produced from current and prior work that has revealed how hard this type of complex analysis is, like producing meaningful results. So when 18 different things are impacting your observational data, how to make sense of this really complex system in data analysis and in model setup. And we could produce a plan to collect observations in a way that we will be more certain will address the highest demonstrated need in models, analysis, data assimilation, parameterizations. So if we determine that such and such parameterization is the leading source of error, then we make sure that the observations that we're deploying are suited for that and deployed in a way that will collect the data needed. While it's difficult to rank research priorities and questions, there seemed like a resounding emphasis on the need to invest in really high resolution coupled model development. So the European Center has an advanced coupled model. It's not there. There are some approximations and assumptions in there still too. The U.S. doesn't. Not all the U.S. agencies have a high resolution coupled model. And we learned this week how high a resolution is needed, and that might not be the case. And there's emphasis that perhaps even regional high resolution could work here because of the really strong need to constrain boundary conditions and get the Gulf Stream separation point right. And Justin, did you want to handle this part? I think you're muted.
Sorry, thanks, Elizabeth. I added in a few research questions which I thought came from our discussion and from the broader discussions, and they include whether and how to include slant-wide convection in the atmosphere. How does the boundary layer communicate with the free troposphere over the Gulf Stream? What are the spatial scales of the Gulf Stream that are seen by the atmosphere? I think that's a really interesting one. How important is rapidly evolving surface wave field near the Gulf Stream to air-sea fluxes? So these are really broad questions and on topics. I'm not particularly an expert on some of these, but I think they've come up in the discussions. And how important is a fully coupled interactive ocean wave atmosphere model with the fluxes imputed in a consistent way? And then, yeah, so that was a few there.
Yeah, and including how to, I forgot to mention, including how to represent processes that span, that pass information or important processes that span multiple grid boxes, and how to represent that both in the atmosphere, such as with cold pools and complex convective systems, or with ocean mixed layer instabilities, how to represent those. Those are some interesting unknowns. And if you go to the next slide, we were trying to come up with an acronym, and the best one we came up with was, and sorry, that's covered up Argus is the atmospheric response to the Gulf Stream. And so Chris brought up that apparently that's a primordial giant or beast who is all-seeing or could perhaps have multiple 100,000 eyes. And so some of these are kind of grotesque, but I really like the one where the person is like seemingly behind a laptop, which is like really relatable to us. And so this could be interpreted, this is like silly and this is where we end, but could be 100 to 1,000 important processes in the Gulf Stream that make it up, 100 to 1,000 ways in which the Gulf Stream impacts weather and climate, or that many platforms deployed to measure the Gulf Stream and its impact, or that many ways to hopefully reduce error in Gulf Stream forecasts and forecasts of its impacts. That's our group's report out.
And I'll just add something, Elizabeth, that it may be too focused on the atmosphere. It says atmospheric response, which is my bit of it. But maybe it could be air-sea interaction and slightly broader, because that also has an A and an R in it. Yeah.
Thanks.
Thank you, everybody. Yeah, definitely okay to end on a fun note there, Elizabeth. You're looking for?
Stop the presentation.
Oh, stop.
Thank you very much. Okay. So, I'm reporting from room 201. Okay, so we followed the script a bit more, but it's probably good that some groups did and some groups didn't, because we kind of get a varied response to this. The first breakout question was, what are the key research questions that may be answered using available measurement technology and existing observational strategies? And so there was an agreement that we want to use existing assets, for example, buoys, to look at background conditions or preconditioning. And then autonomous and Lagrangian measurements for getting the bigger picture. And then synthesizing existing data and satellite data to address our hypotheses. So there was an agreement that, you know, some people are down on certain types of data, certain types of measurement strategies, and it's true that no data is a panacea. No data set is a panacea. No data is good for everything, but it's important to identify the appropriate use for certain types of data. For example, 25-kilometer satellite data will be good for background conditions, but not for mesoscale or smaller dynamics. So it came up that it could be valuable because, you know, someone could go on a little scavenger hunt and piece together a coherent picture using available data, currently actually being actively collected as we speak. But it might be valuable, separate from our aspirations of a field campaign, to create an inventory that points to already available data and where it is stored. So essentially stitching together something like OOI or NDBC from field campaigns that were made in different ocean basins, check what is out there with some background information about the data set and level of processing, really expanding access to the broadest number of researchers. And can such an inventory be a realistic outcome from this workshop? We think that that's a priority for developing our observational capabilities. Okay, so question 2. What are the developments that will be required to answer the key remaining science questions? So can we borrow tools, for example, machine learning from industry? They're developed for a certain task, but can we appropriate them and use them for certain things that we do, repetitive, highly repetitive tasks? So machine learning in a rapidly changing climate can be challenging. You're training on a moving target, so the data set that you use to train might not be applicable 10 years down the line. Also, we want to preserve our physical intuition. A lot of us, you know, we're physical scientists. We want to understand the dynamics. So what about XML, explainable machine learning, where there's some, you know, fusion between using statistical tools while preserving your governing equations and that sort of thing. Increasing resolution is still very important, but, you know, you can just increase interminably and you're just creating more data for yourself. I think we think that it'll be important to find the step changes that are associated with huge improvements in certain features. For example, the number that was we sort of rallied around was the jump from 50 to 25 kilometers in the ocean and from 100 to 50 kilometers in the atmosphere. So I guess I should be clear. 25 kilometers in the ocean, 50 kilometers in the atmosphere, that was described as being a really good target because, you know, you're not talking about 500-meter resolution, so you're not creating petabytes of data or hundreds of petabytes of data, but you're still being able to resolve really important features. And Malcolm's talk from yesterday showing the resolution of the Gulf Stream, or lack of resolution of the Gulf Stream at different spatial resolutions, that was viewed as important. Okay, so then find this false model resolution that is acceptable by the majority of people. And nesting was brought up, but it was determined that it's good for regional studies, but not feasible or applicable globally. And everyone wants coupled models. So is there a need for explicit inclusion of a wave model that mediates exchange between the atmosphere and the ocean models? And then can observations that we propose give us a measure of the impact of the waves on that transfer? So this would be advocacy for direct measurement of fluxes via eddy covariance, current, wave height, et cetera, and needing the whole package co-located. And then looking at how waves affect the overall momentum balance and TKE balance between the atmosphere and ocean. And then wave effects that, shouldn't say that. Okay, that may have been, I copied that wrong. So essentially, how do surface wave effects impact the dimensionless stability or dimensionless profiles that are really the backbone of the core parameterization? I know it's an ongoing topic of research, something that we can maybe dig into a bit with this program. And then how wave effects modify the atmospheric surface layer and the ocean surface layer. We still need to consider the larger scale climate components because of teleconnections that impact sea surface temperature, for example. And then find out where our bulk parameterizations break down. So on the one hand, if you improve your resolution, then you can say that you've got, even if you have very strong spatial gradients, if you have very, very fine resolution, then your bulk parameterization is going to be made in a very small grid cell, and then you've got local homogeneity. But on the other hand, maybe there are sort of emergent properties of having those spatial gradients that is going to lead to a breakdown in MO, and you won't be able to use bulk parameterization. So it's not that MO fails, and Jim was very careful to make this point. It's that it may be being dragged out of where it was designed to be used, and we're acting shocked that it's not performing well in highly heterogeneous environments. Ah, okay, great. Well, I think a lot of people are making the point independently, which is maybe good to note. What are the developments that will be required to answer the key remaining prediction objectives? So can we use stronger assimilation, even though the processes might not be the most physical? So this is the little invisible hand that's coming and constantly nudging. That could be good from a predictive point of view, maybe not ideal from a scientific dynamics point of view, but it could be that we have two strategies, one that's optimized for getting the dynamics correct, regardless of the outcome, and the other that's optimized for improving predictive power, regardless of how we get there. And it's not, terrible to have two parallel objectives. And so how might we create a longer timescale observational program? It was agreed that we need to get a better handle on the spatiotemporal variability. So a super site with HF or X-band marine radar to give you, hourly or on the minute maps of the surface wave and current field over length scales of 10 meters to tens of kilometers or 100 kilometers for HF radar. Can we utilize or deploy more land-based HF radars like what Zaid and Michael have been doing off of Cape Hatteras? Radius of 200 kilometers depends on atmospheric conditions. Depending if you can site those smartly, you might be able to resolve some of the dynamics we're interested in. We need more actively available data to the community. We don't want these data to be collected and sit in a repository for 10 years. If possible, we want the data to be processed and quality controlled in near real time to maximize the impact on the scientific community. And then what can be done on a barge? So we're going to learn a lot in the upcoming DOE-sponsored field campaigns with wind farms. Great thing about barges is you can put a lot on them, including power. You can put really rugged, all the instrumentation you'd put on a research vessel, you can really put on these barges. Can they be deployed in a 2-knot current or 5-knot current when you have large waves? We will see. Profiling up to 300 meters from LiDAR, certainly wind speed, maybe temperature and moisture in the near future. And the barge would be able to hold a tower, but also has enough deck space for other sensors. We need long-term sustainable observations. So cost-effective approach might be to utilize existing technology packages that can be put on autonomous vehicles. And, it was also brought up that piloted aircraft are expensive, and there's an opportunity cost there too. How many piloted flights, for one piloted flight, how many autonomous vehicles could you purchase? How many expensive, but not that expensive LiDARs could you put on a barge that can give you something that is almost as good as an atmospheric sounding? And then we want to make point measurements, but we also need to obtain spatial context to inform how processes down and upstream affect our point measurements. That'll be crucial for comparing models and observations. And then what would be the best way to nest an intensive field campaign within a long-term observation program? Really, we want to be opportunistic, so combine our measurement cruises with maintenance cruises. So as we're going to replace a battery or grab a sensor, repair a sensor, we're doing some transects over a front of interest, maybe doing some CTD casts, making some SON measurements, and then measuring the scalar parameters, temperature, salinity, current speed, but also the turbulent quantities. Obviously, for the purpose of fluxes, acoustic instrumentation that's not prohibitively expensive can give us a lot of information about breaking waves and turbulent kinetic energy dissipation, and that's going to be really valuable for describing these processes. I already said the thing about drop sondes, so we do want to combine stationary with mobile assets, and we maybe don't want to just focus on stormy wind season, but also make measurements of the background baseline calm season. It's not glamorous work, but it's important. Sail drones were described as being more likely to perform better in the calmer conditions, and maybe the sail drone will survive a storm. We'll be able to make high quality flux measurements in the middle of a 30-knot wind with lots of spray and breaking waves. Remains to be seen. And then long-term persistent gas transfer and latent heat flux measurements will be extremely valuable to the community. And then we came up with sea salt emissions, but aerosol measurements are extremely challenging on a manned vessel where you have a full-time tech babysitting the equipment. You put it on an autonomous platform, it could be a nightmare. So yeah, there was a lot there, and I don't want to take too much more time, but That was a really engaging breakout session. I really enjoyed it. It's been really exciting to kind of get down to what we can actually do. So that's it.
Oh, just seemed like you got the right idea.
Thanks. Thanks. So when the steering committee was planning this, one of the things we wanted to do was bring people with different expertise on different scales together. And this group that we had really captured all of the different things we were thinking of. So Sam, if you created the breakout group, then kudos to you. So we did a lot of talking and writing, and then we tried to take it and put it into just a few elements. And this time when we organized it, we tried to organize it into a hypothesis, motivation, bits about the experiment. We started with a hypothesis that Carol Ann presented this morning. We appreciated that one, but we also liked the alternative hypothesis that came in from the chat. And so on the bottom here, we came up with something saying the Gulf Stream impacts the atmospheric boundary layer during quiescent conditions, or even better, the variability of the Gulf Stream matters significantly for the atmospheric boundary layer during quiescent conditions. And this then affects subsequent storms as a preconditioning measure. In terms of our motivation, after talking about it in a lot of different ways, we came back to what we really want is issues with subgrid scale parameterizations to be resolved. And so we said, well, what are some of these issues that we can key in as motivation? And why would we want this? So we love the idea of high resolution models. We'd like to do that all of the time, but we also think that ensemble modeling is key. And for ensemble models, we don't have the computational capability yet to run those all at super high resolution. So for those ensemble type experiments, we need the subgrid scale parameterizations. And we need those subgrid scale parameterizations when we're thinking about Gulf Stream separation because of the symmetry issues. We need to improve on core. So when we're thinking about air-sea fluxes, we need to get to a place where that, which is also a subgrid scale parameterization, is improved. And we need to think about that for stable boundary layers in particular. In the atmosphere in general, our atmosphere models are better at unstable boundary layers than they are at stable boundary layers. Just a general, I think, agreed concept in the atmospheric modeling community. We thought, okay, we want to understand the coevolution of these coupled boundary layers. We had a fun little discussion about whether for the ocean it's just always called a mixed layer, and for the atmosphere it's always called a boundary layer. So we can drop A and O, but it's a side note. And then we also thought, similar to what Nathan was saying, we need the waves in there when we're thinking about the air-sea fluxes. The difficulty in getting the Gulf Stream separation is a key part. And then also the eddying behavior of the Gulf Stream after it separates is an element that we're still trying to understand. And recently, there's been a trend of more warm core shedding. And it's not clear whether this is because of some long-term shift in the behavior of the Gulf Stream system. And then these last two, thinking now on the atmosphere side, non-locally, we have preconditioning of storms, which will impact the weather and climate downstream. Locally, the cloud field after a cold air outbreak is critical for the climate system. And what we might learn for the Gulf Stream region could apply to other western boundary conditions or western boundary currents, right? And one thing in hindsight I wish I had done is I wish I had also brought a poster about clouds, because just in terms of when we're motivating these things, clouds resonate a lot with folks in the climate modeling community. And clouds over the Gulf Stream is a rich area of study, right? We've got all the different types, and we have evolution of a boundary layer that's basically starting from scratch when a storm moves through. The storm wipes out the previous conditions, and you have a new boundary layer forming, and with that, clouds forming in situ. And the details of that are super critical for improving our cloud parameterizations in the GCMs. So when we're thinking about we're going to do this observation system, where do we put it and why would we want to put it there? We thought learn from previous field campaigns,
From SynOp, we have the deep ocean matters, right? So when we have Megan's talk about baroclinic instability, we saw there clearly it's not just the conditions in the ocean mix layer. We need to get deeper. From the KESS campaign, we learned about techniques for making measurements that hadn't been in some of the previous ocean campaigns. We're going to bring those in. For models, we've learned that there's a significant change, and this gets to your point about the step change, right, from your group. When we go sub 25 kilometer in the ocean models and the air-sea interactions, they change significantly. And so this is a point where we say, okay, so now we know what kind of scales we really need to think about observing. When we think about what we've seen so far for where there's a lot of variability, we kind of, after Jamie left, we kind of came to an idea that in addition to being very aware of where conditions matter for sensitivity in an ensemble, we could also say, let's optimize our location for where the most variability occurs. So find the locations where over the course of a winter or over the course of a year, you have the largest variability in the boundary conditions of the atmosphere, largest variability in the ocean eddying behavior. And so that's kind of allowed us to arrive at the region near the Gulf Stream separation, extending towards the shelf. And we can kind of go back to some of Stuart's work from his talk to find a bullseye location for where we felt it would be good to focus. And then we talked about our field campaign's ultimate goal being to improve the subgrid scale parameterizations. And then Chris pointed out this is in some ways a paradigm shift in thinking about these campaigns, because it's no longer a process study that is concentrated, but a process study using longer records. And we're thinking, okay, for this, we want the advanced capability, but they're out there for a sustained period. And so in some ways, we're creating an engineering question, and we have the motivation now for it, and we have ideas for where it could go. And couldn't help but bring up the big old barge, because we all love that, right? And then we spent time thinking about what would we want on it and what would work, right? And we have capabilities that could work. And those are written here as things that testing would need to be done, but could be really helpful. And then a big dream would be you have this barge out there that's actually acting as the communication center for whatever autonomous systems you have, right? So you have sail drones or gliders that can actually communicate with the barge, possibly recharge there or come there to get maintenance when conditions allow. And I think that was the end of where we were. And we all are very excited about this and think that it should happen. And thanks for the time. Done.
And next we have Carol Ann. And I reload this for you.
I'm going to go quickly instead of outlining all the different technologies and everything that we talked about. In many ways, I tried just to summarize. First of all, we think the community, we think there's a lot of data out there, but it's very, very scattered, and a lot of it hasn't really been explored very well. Like you can do, especially you've got some of the satellite products with boundary layer heights and all kinds of things that you could get. We haven't explored it for that. What value would it have, and so forth. So. That was one topic that we had, and we obviously had a discussion of further development of some technologies that would be useful, and we talked about airside drones, remote sensing, and remote sensing, not necessarily satellite remote sensing, but remote sensors, dial for et cetera, and longer deployment underwater drones. So we had some conversations about those. So we then talked a little bit about what we could maybe almost immediately start doing. And that was where we came up with the investigating now some new relationships, perhaps, right? So we had a bit of a conversation again, as Megan reminded us about NDBC and the buoys that they have out there. We should begin a conversation with them right now about adding some additional instrumentation to them. Like, what would it take? I mean, what could we do? Because they're you know, they're not in the middle of the Gulf Stream, but they're, you know, those are weather buoys, and it would be great to have additional instrumentation. And that is something that we could do right away to start that conversation. And as Glenn and others have done, you know, continue to investigate new relationships with the fishing industry, so people who would be willing to take instruments out that they're just out in the area, and we could be getting some longer term measurements from them. The wind energy industry, again, obviously exploring that. And so one of the reasons we're talking about these now is that it's going to take some time on some of these to develop that partnership, right? So the sooner we get going, the better off we'll be. And then I advocated that I think we should be talking to UNOLs for things like radiosondes on their ships, finding a way to just, it's not very expensive. And at the very least, Armstrong, right? Imagine if every time the Armstrong went out in the Atlantic and we had radiosondes a couple of times a day. From that, how much information we'd learn just about the boundary layer, and making sure with the MET, you know, with the MET data and the other oceanographic data that it's just constantly taking, you know. So that's one way. So we were talking about, that's one way to already start in some additional long-term measurements, right? Is to build some of these relationships. On the modeling side, we spent a while talking about coupled Aussies. Like, we really need to, again, start that process up of, it's non-trivial to develop one, and we need to just start really pushing for having the capability for this. And we are not in any sense alone in the community for wanting this. That's an advocate we can do. And I think this came up on Elizabeth, but we had a conversation about coupled data assimilation, like truly coupled boundary layer data assimilation. And we need to be finding ways to be accelerating the research into that. We had a small digression where I was talking about, I was trying to find someone for the Clivra thing, and I wanted this expertise, and I found this one person, and he's now at a company. And of course, Hyode knew exactly who it was, because there's kind of like, it's a very small pool of people doing this. And I felt like there was more going on in Europe when I was trying to find people. But anyway, we need to get this underway. And we talked about regional large ensembles, the development of these in order to look at physics, and this was talked about by others as well. So we then had a discussion about the longer timescale question, and I'm just realizing I'm getting older than I thought, because all of a sudden I went like, oh, Toga Core, there's a story there, and I realized, oh my gosh, I'm one of those old people that go into the thing and they're like, I remember back when there was this. And I do remember, no, I was a child and I was helping my father who was working at the Pentagon, and I remember punching punch cards for him. So I am now one of the grizzled oldsters. But we had a discussion about how did they get how did Toga come about? And so we just had this conversation of Toga. There's a very clear story there. The thermocline in the tropical Pacific and the wind field has a major impact on, and like that is a clear predictor of where we are in the ENSO cycle, and ENSO affects everybody. And so you have to know the depth of the thermocline, and you got to know the winds. And then there's all this predictability that falls out. And I'm not saying that it was then, everyone's like, hey, let's put in the Toga array, and it'll all just go swimmingly. But there was a very clear, compelling it's a measurement everybody can understand. The measurement is directly related to what we're talking about, and it's clearly important for predictability, like the atmospheric and on. And I just said, I think we do need we were talking about, like Mary was saying, why is there not a Toga in the, in the North Atlantic and in the Gulf Stream? And I said, I think part of that is that we need it needs a really clear story, in the way that Toga is kind of a really clear story, and it needs a hero. I'm not sure it's the hero with 1,000 eyes. Okay, but I think, and maybe this field program will be enough to give us a really clear story that makes sort of that linkage that gets the Gulf Stream out of what the oceanographers care about, and we semi-care about, in that, like, it's important on the weather side. It's like it's important that it's there, but it's just there, and we don't really need to worry too much more about it. Kind of thinking, and that's when we went back to start with existing platforms that we're not utilizing yet and relationships and places we might be able to get some data longer term. And then think about what that long-term compelling story is. Anyway, I'm thinking too about the name. For those, some of you in the room are on the butterfly with us, and it was imaginatively called FluxSat. So the original paper is called FluxSat because it was fluxes by satellite, so ergo FluxSat. And then we were like, we have to come up with a better name, and so there was a bit of discussion, and we talked about butterfly, and I can say that there was a round rejection by multiple people on the group, and because then the next thing that happened is there were a bunch of names. I won't mention any names, but you know, Greek gods always comes up somehow whenever people are doing names for things. And I said, so now you'll know who I'm talking about. I said, all right, everyone on this call who has named a mission either S-mode or Wacom does not get to vote. Like that. I mean, if you know, so names are really tough, and but I think sometimes we should spend a little bit of time thinking about the name. So I appreciate the effort to come up with a name. Yes, and those of you who came up with S-mode and Wacom are disallowed from voting on the usefulness and utility of a given name. So I think, Nathan, the next thing on our agenda is just the final discussion, right, and next steps. So a definite next step that must happen on the CLIVAR side, and Mike, tell me if I'm wrong, but we said that we would deliver a workshop report. So that's a clear and definite next step. And as part of that workshop report, oh, do you have a slide for that?
Do you want the last slide that you have in there?
Sure. Oh, I had another slide. Oh, yeah. Oh, I forgot about this slide because I just threw it in at the last second. Yeah. So this is when we've shown this before, but the supersite idea. So I was thinking of this because of the barge, the large barge idea. And that platform right there was actually done by some colleagues who do these for the wind energy. And that's what they look like. And if you can't tell the scale of that, that's a 200-meter flux tower on that, as a 100-meter wind turbine in the back. So when we're talking about platforms with energy and space to put things on, people are talking about things like that. It doesn't mean it has to look like that or anything like that, but it is, I think it's a really great idea because it absolutely is that paradigm shift. A process that we are not forced between either minimal observations for long periods of time or a maximum of observations for a very short period of time. We can go beyond that just a bit. And I think that gets us into what I think of as the null and the alternative hypothesis. The null is the storms are really important. The alternative is not the storms, it's the quiescent conditions that are really important. But we need to be measuring both, right, for long periods of time. And we are maybe at the position now of being able to do something where we can do power and size. And then it just kind of frees you up to think about this. So let's say you had a barge or a platform. Would you moor it someplace? And if so, where would that be? Or would you, again, put it in and let it drift down the Gulf Stream and measure all along the way and then just tow it back and start it over again? I'm not saying there's a right or a wrong way, but it just, like, we need to start thinking, like, these are all kind of fun things to think about. That's the fun thing,
So my intuition is we'd want to have it in a region where the Gulf Stream would waggle across it, and it would just sit there, and the fronts would come to it. And my worry about putting it in the Gulf Stream is that it's going to do a really good job of tracking the peak current and then the sort of like area of convergence. So there's a place for those, and the X-bar I think would be a perfect complement to a fixed instrumentation platform.
Anyway, but see, these are the great, I mean, once you start thinking of, freeing it up, right?
Yeah.
Then it's like, well, what could we do? What if we had such a platform? What would we do with it? Where would we take it? Jim will be happy to hear that the large barge is the phrase that came forward. All right. So All right, so Chris has a comment. Do you want to read that?
Yeah, happily. I'll use this. Yeah, so Chris, I can read your comment, or you can ask your question on mute. Yeah.
Sorry, can you hear?
Yes.
Sorry, it's just coming back to one of these points people made about comparing with models. It sort of occurred to me that our next operational forecast model might be particularly interesting to confront with any new or existing even observations of Gulf Stream interactions. So this will be coming in the next year or so, depending whether or not we sort out our HPC, but it sees a separation of the extended range and the medium range systems and some changes to ensemble size and resolution. But the result is that every single day we will start issuing coupled ocean, ice, atmosphere, wave forecasts. So we'll have a 15-day, 51-member ensemble with a 9-kilometer atmosphere and a 46-day, 100-member ensemble with a 30-kilometer atmosphere. This will happen every day. So it doesn't require any additional experimentation to sort of investigate the impact of resolution at these weather timescales. And it might also be useful for identifying other more targeted experiments.
That was so good, we're all speechless. Go ahead.
Yeah, so Jamie asked if Chris could expand on what front? Confront means. Yes.
Well, I think any detailed process study, I mean, this sort of data is vast and gets issued operationally, but probably doesn't very often get investigated in any detail. We're very good at doing skill scores and evaluating how well our systems are performing in a predictability sense, but it often takes a lot more manpower to do detailed investigations of the processes. If there's interest in the community to collaborate on this sort of thing, I'm sure we can find a way to sort of make that happen.
So Elizabeth, I don't have memorized the steps that you had, that your group had talked about for sort of, for the next steps. So just a few concrete things is, again, the workshop report. We'll probably give you all an email at some point when the organizing committee's gotten it together and done something for comment and what you think we've missed within it. Some very easy next following that steps are opportunities for getting together and having discussions in terms of upcoming things. There's the session at, is it AGU or AMS that you guys are doing? So Larry says it's an AGU fall meeting, and it's in conjunction with their CLIVAR working group, mesoscale fronts and eddies, because I realized, was it the day after the deadline? The day or something, that indeed there was a deadline that was way earlier than I had anticipated there would be for both AGU and AMS. I think I missed AGU by a week and AMS by a day or something like that. And so I did ask Hyode and Larry if there were a bunch of people who put in about Gulfstream stuff, if there were enough, and there was, they got enough space, of course, from AGU and everything, if we could have sort of a special little, one of the sessions or something, one of the, things sort of dedicated to Gulfstream issues with thinking about moving something like this sort of forward, right? With this kind of in mind. There's also, of course, the workshop next year that you guys are doing as well, and we could consider having some discussion there about this, because it dovetails very nicely with their work. So those are some concrete things. Love to hear some more concrete things like, is it, to at least sort of keep us going for the moment, Slack channels, monthly webinars, that are organized. So, I mean, these are all things that I've thought of, but any comments from people out there in terms of keeping at least a connection going and growing? So Elizabeth mentioned a CLIVAR study team. Mike, do you want to make a comment about that?
So yeah, that was following on, I think, Young-Oh Kwan's suggestion this morning that with the sunsetting of the US AMOC science team, which was a 12-year endeavor that included or attempted to include all funded PIs in the US or project PIs and down to students on those projects into a single team that had that 12-year duration across NASA, NOAA, NSF, and DOE funded projects. So it was 60 to 70 projects at any one time, 120 or so investigators. Large effort, commissioned by the funding agency manager. So what I want to say in terms of that construct, it's been made very clear to the project office that is commissioned from the agency managers. So what I'd say is a recommendation for that a science team could be an effective organizing principle, could appear in a workshop report. Does not mean it will happen because agencies would have to commission it. So just there's a caveat there, but I think there's still things that can happen. This idea of Slack channel, monthly webinars, people kind of organizing on their own as well. Side meetings at AGU, AMS, and future ocean sciences meetings. There are other ways to keep group together and independently setting up your own kind of web platform for people to contribute to. I think that downstream, some of these ideas about doing the literature review and what are capturing the outputs from the previous field campaigns and assessing our observational platforms in situ and satellite, that work, there could be a web platform for that, right? A repository of sorts that could be developed. All that has to come with funding, and if that were to come through, say, a CLIVAR project office activity, it would have to, somehow we'd have to have agencies agreeing. A science team or dedicated or working group of sorts.
Yeah, so just thoughts that you have. Maybe one way of constraining this is saying, not that we're going to ask CLIVAR to do another workshop like this. I'm just saying, if in 2 years from now, we got together at another workshop, so just think about between now and then, and said at that workshop, we're actually going to start sketching out the details of what observationally we're going to do and modeling wise we're going to do. What would need to happen between now and 2 years from now for us to feel like that's a possibility, right? I mean, think about it in that way. Like, there's lots of things that we're at and not at. So Megan's got an idea.
So a lot of this work is going to take funding, and I haven't seen any program managers here. Who are the program managers who we might approach for, say, going to NDBC and working on, adding mixed layer depth, some sensors to the mooring line to measure the mixed layer depth, or some other sensors? I mean, who are the program managers that how do we do that? How do we approach them?
Well, yeah, so if I can hop in here too. So the funding agency programs that supported this workshop are a good first stop. So with the workshop report, if there's some details like this that emerge, right, in that report, our co-chairs will have the opportunity to brief the agency managers on the effort and can drill down to some specific recommendations like that can be requested in terms of follow-up. and can position us for future dialogue with the interagency group downstream. But those program managers include the Physical Oceanography Program of NASA, the Global Ocean Monitoring, what is it now? Global Ocean Monitoring and Observing, right, GOMO of NOAA, which you're familiar with, which is where I think maybe the NDBC enhancements might be targeted, those kind of recommendations. And then NSF Physical Oceanography and the large-scale, the Climate and Large-Scale Dynamics program as well, so the atmosphere, bringing the atmosphere. Oh, and I left out the Climate Variability and Predictability Program at NOAA as well. That's Sandy Lucas's effort that often supports the field campaign work. I think Sandy, just to point out, I've seen her her name pop in. So she's been popping in intermittently during the meeting, as has, who was the other one from? Jesse Carmen from the Weather Program Office as well. So as we're getting down into the storm scale, we're focusing on storms as well as the mean state. This is perhaps of interest at that time scale and could bring in the weather program as well at NOAA.
That was actually one of the reasons that I went through CLIVAR to do this workshop, because I thought if I put in a proposal for it and none of the agencies are even interested in funding a workshop on it, that'll be sort of an answer as to whether there's much interest. So I thought at least there was enough interest for them to see what is their interest, is this a possibility, where would people go with it? So I think we have to capitalize on that, right? We have to develop that relationship.
I'd make one more point, and I can throw this over to you, Caroline, because you're co-chairing the effort. But for those of you who aren't aware, and I don't know that we've talked about it that much here at this meeting, there's this one-year study. Sam was in part hired with funding from NASA, NOAA, National Science Foundation, and ONR to develop within a year a strategy document for a global coupled boundary layer observing system that would bring together our satellite assets or make the case for new satellite investments, our in situ observing system, enhancing what we have, but doing the new things, like what's being described here with super sites and the like. And then piloting those efforts over the subsequent 2 years through field campaigns and pilot deployments. So this Gulf Stream effort would fit nicely within that time frame, along with the TPOS field campaigns that are on the docket as well. And then, and some high latitude things that are being talked about as well. And then go global. And this is where our partnership with OASIS really will be important downstream in terms of really implementing a global strategy for sea change or step function change in our global observing of the mixed layer and boundary layer.
Yeah, so I didn't say anything about that CLIVAR working group, but that was another one that was it's not a working group. Is it a working group? It's a study group. Okay, sorry, to get the terms correct. But that was another one, and that was requested by the agency managers. That was, no one put in a proposal to them and said, we would like this. They came back and said, we need such an observing system, and we need to know where we could do some pilot studies. So I haven't said too much about it here. Some of you are on that study group. But there's clear synergy in terms of things that we might recommend, from the study group.
Elizabeth has raised her hand and lowered it a couple times.
Is it back up?
I was just gonna echo what Megan said, that it seems worthwhile to have funding to produce the type of research that's needed to guide the field experiment, or like what's next. I agree that there's some things we could totally do now, but that some synthesis and pre-field campaign things could be really useful. And that would require more funding, not like what I'm gonna produce on a weekend, which is like hopefully not much.
And so I was just going to say, from the modeling perspective, so I mentioned ERIE yesterday, so that's funded to start the start of next year. Carol Ann and Jim are on our external expert panel, and so hopefully can kind of influence. So I mean, the main question is, for us, what is the impact of mesoscale ocean on weather and climate? That is our project question that is funded for 4 years. So that's what we want to do. And so hopefully with Carolyn and Jim can kind of influence us and ask the questions and kind of get us doing the kind of analysis that might take us down that road as well. So we should keep in touch with this group in some way as well, so that we can kind of keep that communication open.
Yes, I think some of it is, at some level, some of it is again, people looking for separate funding, some things that are currently funded or about to start up, and maybe we continue to inject this flavor because we might get things out of it that's very useful for it. And then some of it is just convincing those of you who have, interest in technology that maybe could be developed a little bit more for something. If this can be used, if the workshop and then future, and an outline of sort of future plans might be helpful as you're, applying for funding. Clearly, when I'm saying, in 2 years, sort of a system, what might we do in 2 years? That in 2 years, we might say, well, we need like 3 pilot studies that are each trying out blah, 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 blah. And, that could be sort of in the mix. But I really, and I think, I think the whole organizing committee, but I know Nathan and, we did not want this to be a workshop of what do we know about the Gulf Stream and what questions are out there. It really is meant to be, we want to do this. We want to make this experiment happen. It's important. I think it'll be highly valuable. I think it's timely. Another thing that I just thought of, Malcolm, so the other thing is we might think about our European partners. We have some European partners here, but in terms of funding and outlook and what they might be able to contribute, I think the more we can reach out and bring them into it too. There's no reason for this to be like a solely US funded effort. In fact, that's kind of silly actually, but so again, so looking to this community to help us sort of make those connections and who else not in the US. And then if it's of interest to, folks studying the Kuroshio and others, as some examples, as we collaborate back and forth with what they're doing with Hotspot and other things, again, that community would be useful to bring in. So the more connections that we have, I think the better the whole program itself will be.
I strongly agree.
All right, well, we're a little early, but no one will probably complain too much about that. Are there any, I don't want to cut, I don't see any hands up. Are there any last thoughts by anyone about ways that you feel are particularly valuable for keeping this connection going and us continuing to talk about next steps, or any other suggestions that you might have as we go about sort of setting out the workshop report and thinking about some next steps based on conversations we've had here? Megan.
Sorry. You were saying that that we might coalesce around the air-sea interactions sessions at AGU, but I also think that Hyode was talking about the hotspot group having a western boundary current or mid-latitude air-sea interaction AGU session, and I do think there's a lot to learn between the North Pacific Western Boundary Current work and this work. There's a lot of the same questions, a lot of the same similar solutions and problems, and we should be not working in isolation, I think. Hotspot, that's a hotspot.
I also think it might be useful if we were to do something like a monthly or bi-monthly webinar or discussion group or something. I found those to be useful in other contexts. So for our working group, we try to do every 2 months, and I know no one else wants another, something else scheduled, like need another hole in your head. But it might be useful to keep momentum going, and then also to kind of inform. We could have like short, informal, like 15-minute, talks by a couple people, every month or two. Maybe updates on, current efforts and things like that. That might be useful to keep momentum going among the community. Like we can start off ourselves and.
That's a great suggestion, and I don't want to sound too young, but Discord is a great platform for having a pop-in conversation. And, it's horrific for professors who have to deal with it as a cheating platform, but if you want to share information and then just have a quick video chat that isn't another, block of time we're using WebEx or Zoom, it's a pretty nice hybrid communication platform for loose collaboration, I found. So.
I'm just laughing since I've already done the old grizzled thing. I was just thinking that's what my 14-year-old's on all the time, Discord, so I can get him to help me. I totally have jumped the shark. So, yeah, any.
It's not TikTok, okay? I'm not going that far. But,
I'd actually be easier with TikTok. I will also say, as we're thinking about developing this out, I personally, and I know Clivar, and I know many, if not all of you, also have an appreciation for bringing in underrepresented communities. That can be either as stakeholders or as part of this, future program, bringing them in. There are some ways, talking with like OOI, there's some ways that we've talked about funding to do that. There are programs for going and giving talks at various places where we could discuss Gulfstream, upcoming things, encouraging people to look at that at various institutions. One person who was supposed to be here and she could not, she ended up getting COVID, of course, because that's what's wiping all of us out, is Jill Zandy, who's the executive director of a program called MATE. Their national championship is tomorrow. She's the executive director, and like I said, she sends her apologies because she's had this on her calendar now, so ever since I started telling her about it like a year ago, about it, that she could not be here. But we're just thinking like right at the outset of education, outreach, inclusion, and so, so we're talking about the possibility of having a very Gulfstream-centered MATE competition in a few years that would be, would also promote some interest. If you don't know what MATE is, it's an underwater robotics competition. I'm trying to remember where it started. Did it start for community colleges? But now there are high schools that do it, and universities do it, and it's even down into grade schools, and it's sort of it's a big outreach effort. There are many other outreach efforts that we could do, but I think we should have that right in the DNA to begin with, that we are finding ways to reach out and be very inclusive of our efforts. So I didn't want to leave. I was going to talk about that at the beginning, and then I forgot till just now. But I think that's really important for us.
Yeah, and with MATE, I found out about MATE through offshore energy projects that are being supported actively by DOE now. So I think if we can find a way to maybe cross-pollinate in that realm, I think there's a lot of interest, especially people get into science because they want to solve problems, big problems. And if we can maybe put our Gulf Stream related studies in the context of, well, how do we integrate this into the offshore energy, type questions, we could get a lot of people interested in what we're trying to do here.
Well, thank you. Okay, so this is the thanks to all of you for coming. I am amazed not only at those of you who came, given that occasionally there are lots of questions about travel right now, and I'm also amazed at the folks who have been on so valiantly online for so much of the time. Your perseverance. I am woefully incapable of being on Zoom for more than an hour at a time before I have to get up and get out and do something else. So really appreciate both online and in-person members. And I really want to say a big shout out to Sam and Mike for doing the hard work of organizing this. I also want to thank Jessica, who's hiding out there, as our Woods Hole person helping organize a bunch of this. And then the whole organizing committee. Yeah, that guy in the booth. Thank you. I'm not even sure. He left. Yeah. Who was it today? Was it? Val. Oh, it was Val. Okay. All right. That's what it's like as a Matt. I don't know who it is today. Yes, so guy in the booth. And then the organizing committee. So they've worked for a year on this. And especially Nathan, who I had not ever, well, he says, oh, this is another one where he said you met me or you saw me at a conference or something, and I have no memory of that. But before we started to do this, I didn't know him at all, and it's been a real pleasure to get to know Nathan over this and have, again, importance of reaching out to people you haven't met before and bringing them into the conversation. So really happy to work with you, Nathan.
Thank you very much. It was a real honor.
Thanks, everyone. And now there's a bunch of hands.
They're
clapping. Okay.
They have a new idea about the name.
Oh, yeah, no, doesn't have to say about the name. Is that right?
No, I was joking.
Oh.
Yeah.
Youngo, is your hand up? Oh, waving.
I tried to clap.
Okay. Oh, Mike's got one more thing.
Yeah, one more thing before we depart, then we need to acknowledge Carol Ann's effort here.
Oh.
We had a discussion. Carol Ann, many of you may not know this, she serves as our chair of the Scientific Steering Committee for U.S. CLIBAR. And we were at an annual meeting for the Scientific Steering Committee, and during that, at a break or following, we had a side conversation about the importance of this topic, and that there would, there's this gap as we've been focusing on Western boundary currents and the work with CLIMODE a decade previous, our efforts with KES, and this kind of need to come back to the Gulf Stream. And in light of the work of our working group on air-sea interaction at frontal zones and mesoscale, this was a prime time to do this. And so I want to thank her for taking the ball and running with it and bringing together the team, the SOC for this effort, and hosting it here at Woods Hole. Sorry, caught myself.
Oh.
Now, 2 weeks we're going to be at UW, so sorry about that.
No, I hope you call them Hui when you're there.
Yeah, exactly. Yep. So at Woods Hole, which has been a great campus for us to have this on. We're overlooking the Atlantic Ocean.
Yes.
So this is great.
Cool.
All right,
thanks
Caroline.
everyone. Have a good trip.